Salve a tutti, benvenuti a questa presentazione. Oggi vi parlerò, right mode, English. Today I'm going to speak about the art of procedural, how to create your own words. Now I need to do a brief overview before starting right into the conversation, into the presentation. I'm not going to show any actual code into this. It's not going to be highly technical in terms of what is to develop the specifics of every technique, mostly because if I were to cover all the subject covered in this presentation, it would easily take several hours per point of the bullet list. So I'm going to do a quick overview, what tools you have at your disposal. So yes, the art of procedural, create your own words. Overview of the most common procedural techniques. Let's take a look at what we have in our slides. I will do a brief introduction about myself and why you should listen to me, why use procedural generation, and how does it work. So the actual technical part. Who am I? Good question. I'll be brief about it. I have a degree in computer games production at the University of Lincoln in the UK, and then a master game development in Birmingham. The master was a really good learning experience because it was a more hands-on game development training, while the computer games production was more focused about project management, team management, and stuff like that, although we covered development-related subjects. The master was especially useful because it started introducing me right away in the world of, in the actual industry. So I started with an internship at Sony last almost 1 year when I worked on a cancelled PS3 game called King Cook. It was actually pretty fun, but they pulled the plug. This happens. And then I worked on a small indie company called Dixidiasoft for 4 years as art director. It's been a pretty good learning experience, to be fair, because it was a pretty good hands-on approach on how to manage an individual team, how to relate, how to keep the morale up, which is all stuff that will be really useful later on. Then I did a number of freelance works ranging from 3D, web development, all stuff like a technical art implementation on demand, little things. Then I had the honor of working as lead artist at Ovosonico for the game Last Day of June. I hope that someone of you played it. It's a really nice tear-jerking game. And currently I'm working as technical environment artist at CD Projekt Red. You may have heard of the company. And are currently working on Cyberpunk 2077. So let's go into the procedural. Why should we use it? It's actually a very good question. Today we are in a situation where the amount of stuff in game worlds is remarkable. Game worlds are getting bigger and bigger, and we can't get away with a flat texture with trees on top of it. We may need just a bit more. And in this process, the human hand alone may not be enough because there's always the human error. So even the most skilled artists mess up sometimes. So it's better to try to automatize, especially when we need mass production of assets. Let's take a look at the biggest game maps ever. So the laser. So this ludicrously, microphone, don't leave me. This big red dot, the map of Grand Theft Auto 3. Any of you played that game? Race, I was expecting that. So far less famous game, Just Cause 2, and it's already much bigger. We're talking about 400 square miles. Then we have Asher on Call. No one played. Anyone played Asher on Call? Nice. 22 square miles. Then we have Test Drive. I never played Test Drive, honestly. I'm not even sure. 2006. Then 5,000 square miles for Fuel. Although driving games, they get off pretty easily or that because they don't really have to populate everything in between the roads. Still, 5,000 square miles. Then we have Guild Wars Nightfall, which is this huge map here with a grand total of 15,000 square miles, and it's also this small map here. And the next one is Lord of the Rings Online. We have 33 square miles. And all of these are dwarfed greatly by the biggest game map ever made back in, what was it, 1985, 1986, The Elder Scrolls 2 Daggerfall. Completely procedurally generated, it was the size of Europe, walkable. So when they argue between, oh, it's bigger Skyrim or Oblivion, guys, no, no, they're all dwarfed. And this is the first time that procedural generation was used to generate a ridiculously big world. And it was quite the feat for its time. So it's not just about creating a game world, but it's also about filling it and making it more interactive. We need to make sure there's more stuff to do in the game world itself. So let's take a look at a case study. This is Darkest Dungeon. Has anyone played Darkest Dungeon? So you all share my pain in playing this game. This is painful to play. Darkest Dungeon is a dungeon crawling game which revolves heavily around generating the game maps every time you enter in a dungeon. You don't know what to expect. And this is a core element of the game. Like, it's built around that. This is a form of procedural generation. This is a form of procedural generation. Every time that you enter a new dungeon, the map is completely re-rolled and changed. And this factor of uncertainty makes the dungeon scarier. In this game, the feel is conveyed through this. Same case for this one, Legend of Grimrock. I will expect many less arms raised. You're like the king of gaming already. Really. Good, good. These games are revolving around procedurally generated landscape and encounters. Like, all the enemies are re-rolled and generated according to a set of rules on the fly. Okay. So, games that revolve around generation. We've seen Darkest Dungeon, but is that everything we have to do? Is that everything we can do? Let's take a look at this game. This is slightly procedural. Actually, everything in this game is procedural. It's a whole universe, explorable. Every creature, every model of the creature, every setting of the skybox, every environment, everything in this game is procedural. And for our time, this is a pretty good fit, actually. This is a pretty massive, it's a universe-sized game. It's a universe-sized game. Like, even if you want to explore the whole thing, you may need several years of continuous non-stop exploring, and you can still find new stuff. Again, it's not, the variety may not have lived up to it, but it's still an incredible fit. These are sandbox games. Previously, it's been mentioned Minecraft in another conference, but games like Minecraft are procedural. They generate the landscape, they generate everything, and there is this concept of exploration that allows us to see in detail what the world has to offer every time. But it's not only about games or about the gameplay itself. It's also about the pipeline. This is the most technical part, and I think many of you that worked in the game industry and simulation industry can relate to this. Being able to streamline the pipeline and making sure it's easier to develop stuff in a more cohesive way. For instance, if you are, I don't know, making clothing, rather than manually model all the clothing for all your characters, you may want to do the cloth simulation in your software package of choice and then bake procedural maps for the physics, so you know which parts are more adherent and less prone to physics simulation, and more parts are more adherent. Or naming convention, which is the bane of most teams, having a cohesive naming convention when working in a file, and you find that jammario01.fbx, and you have absolutely no clue what is that. This is avoidable thanks to procedural generation, because we can streamline the automatic naming of files and management of them. And also, we can take off the bunch of the workload. Let's say we need to make a massive open world game. We may want to have stuff like SpeedTree, which is a software package for procedurally generated trees. We don't want to manually model every tree, every branch, everything, because it's too much stuff, too much work, and at the end of the day, the amount of work we're doing is not worth the amount of content added. So we can take off this menial stuff and focus about the more awesome things. And this is the third point. We can actually make sure that the stuff that count are the stuff that we spend most time on. Let's take a look at this. This is a procedural generator for houses. It's completely parametrical. You don't have to input anything. Bricks, textures of concrete, and everything else is all generated. And this is the same generator making all these 6 buildings. And this is generated by a click, by just giving some input. This is the kind of stuff that perhaps when doing a driving game and you want to like run at 100 miles per hour through like a massive city, you don't really want to model all the buildings that you will never see in detail or standing still, especially because with a motion blur, you won't be able to look at it directly at all. But this is the type of content you want to skip. Or generate textures. This is more game development relevant thing, but it's nonetheless pretty important. Today, we can't get away with just a picture slammed on the building and call it a day. We need to actually have multiple maps to make the materials feel realistic. So there are many programs and many systems that allow us to generate super cool maps with shiny effects with a click. Because painting manually all of these maps, it's just not feasible today. It's just not feasible. So, how it's done. Let's take a look at the more technical side of this. Just a second. I apologize. Whoop. Falls off. Better. So, we have 2 types. As established, we have 2 types of things we actually have to make: the content and assets. The content, of course, being like the landmass, the trees, the architecture, the characters. The game, other way around. The game asset is all this stuff. The game content is actually interactions, I don't know, crafting, maybe rolled enemies, maybe random dungeons, this kind of stuff, the thing you actually play. Okay, and we can have 2 approaches. We've shown some examples. The first one is low procedural. The second one is high procedural. Low procedural is where you have the game is partially procedural, and high procedural is where like you're revolving around it. It's like we have a tiny fraction of the game as only one feature maybe, or just like one location, or the entire game procedural. And these are usually the games that fall under the umbrella of being explorable, replayable, infinite content. When you hear these buzzwords, this content, when they present a game, usually it's because there's a lot of procedural generation inside of it. So, about the asset generation, let's take a look at map landscape, architecture generation. What we want to take a look at is character and vehicle generation, because it's another topic that is way complex, too complex even for an overview now. But improved texturing and detailing will be covered. Again, this is going to be an overview, so please don't get mad at me if I don't cover it enough detail as you were hoping for. Let's start from the basics. Noises. Noises are the basic of every procedural generation. Of every procedural generation, and they are the basic brick of every technique. So, regardless of what they are, depending on the algorithm, they can change. They could be Voronoi, they could be blur, Gaussian, they could be fractal. There's can be cellular. There's many algorithms that generate different noises, but according to how we combine the noises, the parameters of procedural generation, and the techniques, we can get completely different results with the same base algorithm. And this is what gives variety to procedural generation. So, let's use this. Let's use this to create a haymap and the geometry of the world. What is a haymap? A haymap is a grayscale that is used to deform a flat sheet of triangles or quads to create a game world. Like usually, if any of you has used a map editor or a terrain editor from Unity or Unreal or any other game engine, you've been working with terrains, so you really know what I'm talking about. But let's assume that we don't really want to manually make this. Let's assume that we want to get to this point, so merging the 2 pictures shown before into this automatically, and we want to get a cool-looking terrain without actually having go through the whole process of painting it. Let's say we have the size of Europe to fill. we need to generate a word. We start with the noises, and we need to, from the noises, of course, we don't get anything realistic. We don't get anything usable. So we need to start refining it. How do we refine it? We simulate all the geological features, all the geological stuff that could normally happen to a terrain. So rain, wind erosion, weathering, coastal erosion, sediment deposit, cracks, rivers, everything that can make our game world more interesting. So let's take the noises as before, and we see the same terrain with two variations of the noise, but an amount of frequency that changes. So in the first one, we obtain smooth, billowy hills, maybe pretty cool, you know, the Shire, something quiet and nice. Then we get these Himalayan-like mountains, super sharp and super jagged. This is the same terrain, but with two different generations. We don't really have to use only one of those. We can actually combine them together. Combining them together can allow us for more variety on the terrain. And when we have this, none of these actually look realistic still. So I think we can do better. We can do much better now. So in this one, we see the terrains, the smooth, billowy terrain, when we apply an erosion filter. How does erosion filter works? It takes the curvature of the terrain. It's calculating using the curvature, so how much is convex or concave a surface. It's actually calculating whether or not it should be erased, should be lowered, or should be higher due to the deposit of sediment. And the other one is coastal erosion. Like we decide a water level for the sea, and we generate all the nice coasts and the steep cliff undersea, where the sediment stop deposit. Again, this is a way to simulate a realistic landscape, of course. So if you're going for something like Minecraft, you can actually stop at the previous step and just have a noise to generate a world map. This is when we want to get serious into making it photorealistic, make it look legit. With the data generated before, we already have a lot of material to actually texture the world. In this case, we're talking about exposure, which is this red thing here. So the part that have been most exposed to the wind and to the weather. Then we have the rocks, so the steep cliffside. We can use the slope of the generated terrain to calculate which should be more exposed and less covered, perhaps with ground. Then we have the blue, which is in various degrees the sediment. So where the soil is rich of minerals, perhaps we want to use a greener texture, or if it's like a barren landscape, we want to use a more rocky texture. We can decide. But we have the data, and the light blue, it's regular grass, just exposed, flat, boring, but we have grass. And this is the result. This is not touched. No human hand went into this. This is all generated procedurally. And yes, we can add more stuff. We can make it even better. But as a test drive, I think we achieved a pretty decent look right off the bat. Like, for not having to do anything, this is a really pretty decent, I would say. Let's not stop at landscapes. Let's go on with architecture. We can use the noises as before to generate buildings. Noises can be used either to generate at a city level, so decide which part of the city could have more density of houses, or which part of the city could have, for instance, richer houses, or simply put, like more rundown area or undeveloped land. And we can also use it to create buildings, so to decide which part of the building has been more weathered, has been humid, create variation in the plaster if we're using plaster, or in the concrete if we're using concrete. And we can also use it for repeatable stuff. So all the tileable architecture that we want to build on top of each other and repeating, think about the Milan Cathedral. The Milan Cathedral has architectural elements that kind of repeat just a bit. It's like there's a lot of them. We don't really need to manually place all of them. We could do that procedurally. We could do that automatically and create. I could make a generator to make the Milan Cathedral, then press reroll, and I get, I don't know, the cathedral, not Notre Dame. I can get the Cathedral of Cologne. The sky is the limit at that point. I mean, as long as I have made a generator for the architectural pieces and a generator to combine them, tileable pieces can be reused as much as we want. Let's take a look at this. This is in practice. Noise and splines to make architectural shape. This is a trim, as you can see. We're re-rolling the trim every time. We're just changing the noise. So it's like literally a re-roll button. And then we make them round. It could be anything, vases, pillars, columns, shelves, any type of thing. And using these two, we can do this. This. It's completely procedural, no human hand. By any means, it's not perfect yet. Like you wouldn't see, oh, it's real. But we're already getting there. And again, for no human hand involved, we're already pretty far off. We used, as you can see, the trims as before as pillars. We use them to draw the arches. We use them to generate all the, all the capitals. Oops, spoiler. All the capitals. And yes, as I just spoiled for you guys, this is another way we can use stylable pieces. So what we are doing here, we're telling the procedural generator that depending on the size of the building and on the height of the building, we should change how the building looks like and how everything should be assembled together. So we're telling them every X meters, every X centimeters, add a new floor instead of like growing one floor. Again here, I really don't like brutalist architecture, but it's still pretty hefty to see. This is pretty custom. Like you wouldn't see like in every building. It's not a standard thing. But you can create pretty unique shapes. You can actually go creative with this. It doesn't have to be like the early PS1 Spider-Man City, which was all block because they didn't add the computational power to run it. Today we can go wild and crazy with this because we can make the city have so many shapes and so many forms. It doesn't have to be a modern city. We can use procedural generation to make a medieval town, but even a spaceship. We can do whatever we want with this. So now we have the models. Let's make them look more real, if you will. Substance Designer and Substance Painter. Has any of you ever used those programs? Raise hands, please. Don't be shy. Okay, I was expecting a bit more. So I'm gonna be a bit of a shill now and advertise this program to everyone else because it's awesome. The company working on it, Algorithmic, came up with a terrific idea of being able to paint directly on the texture and directly on the model and directly using filters and shapes. And then again, this lost me. Okay, so most artists. Like in the industry, this is a standard now. It's almost required in any CV you would see in the game industry. They will ask you knowledge of PBR, which is physically based renderer, which is the photorealistic stuff. And they ask you Substance Painter and possibly Substance Designer, depending if you want to be a texture or a 3D artist. But they will always ask you. And on this account, tileable textures are super easy to do. This is the thing we were discussing before with the architecture. We can do that for textures as well. So repeating bricks, concrete, literally anything, grass, rock, and everything you want. Let's take an example. This is procedural, no human hand. It's been made by my colleague Mark Foreman, which works at CDP as senior texture artist. And as you can see, there's quite a lot of detail in this one. And this is a material. There's no 3D here. This is a cube with a material on top of it. There's zero 3D modeling. I mean, it looks detailed, but I think we can take a better look at it and see if it's detailed enough, even from this side. And again, this is procedural. This is all made with Substance Designer. And it's been the splash screen of Substance Designer for a while. I think last year. And as you can see, like everything, the roses, the lichens here, all the cracks, and the little details. To hand paint this, it would take months. Solid weeks of work per map to hand paint all of this. Even skilled artists would struggle to make it in a reasonable time span, at least with this detail. Let's take a look. This is how the thing was made. Okay, yeah, this is the start. As you can see, parameters were added on top of each other to make it look nicer and nicer with more and more detail. And you see at some point you can actually see the IV changing. The IV have been re-rolled. So by just changing a parameter, I get a completely different texture with one click once I made the whole system of procedural generation. Let's take another look. Oh, yeah, this was it. Let's take another look at any other techniques. Weathering. How to make weathering? Weathering is to make regular buildings, like with flat surfaces, to look super realistic. This needs to stop falling. Okay. So, oh, here we are. I'm back. So, flat textures with realistic looks. Let's take a look at details. Broken glass, stains, humidity here, build up, dust. This is the kind of stuff that we want to add to our building, to our everything. It could even be characters, to be fair. This applies for characters as well. How do we do that? We do that with the three techniques. The first one is particle-based simulation, which is used to simulate everything that actually falls. So it could be dust, it could be rain, it could be any form of leaks. Everything that actually follows gravity and leaves a mark on your building, on whatever it is, it's actually particle-based simulation. We simulate the actual fall of things on top of it. Then we have the vertex colors. Vertex colors is storing the RGB, red, green, and blue data into a vertex, and then we read it to decide which side, for instance, of this texture should be brick, which one should be plaster, perhaps. So instead of actually saving a mask of where we want the brick, where we want the plaster, we use vertex data. Or we can use interpolation. Interpolation is actually used to enhance the vertex data. Let's say that this is a vertex here, and there's a vertex here. You would see like a flat gradient of bricks just fading into plaster. We make it more interesting with interpolation. We give them a grayscale map and say, yeah, make it like really jiggity and like with all the cracks and whatnot. We do that using interpolation. So with these three techniques, we get, for instance, this brick texture and this ivy texture. Both of them have been generated procedurally. So again, no human hand involved. And both of them are being used doing these three techniques plus generating the base materials. So this is, again, not a building, not a 3D object. This is a cube. It's a flat cube with a material on top of it. And again, this has zero human hand involved. The only human hand is the guy that spent a lot of hours doing the base system to make it procedural. Let's take a look. This is the breakdown. It's a material. Like you can apply it whenever you want, and you get this distortion. And this is the map. So we have the the curvature map. We have the normal map. Here the diffuse map. Then we have the hay map, which is used to distort the cube so it looks 3D. So this is where like the hay map is white. This is where the hay map is black. And then we have the ambient occlusion, which is to simulate like the lack of escape of light in the concave surfaces. So when you have a concave surface, you want to make it look more deep, more popping out using ambient occlusion. And this is the final thing about it. A lot of time, every time I speak about procedural generation and I speak about tech art related to this, I get the question, but what about making the human hand obsolete forever? Now, I've been advertising a lot procedural generation, but this is an important matter that I need to address before wrapping up this presentation. We can't get, in my opinion, to the point where the human hand is no longer necessary for a simple reason. Humans understand what a feeling is, how to convey feelings, how to convey beauty. A machine doesn't. So even if you make the smartest AI, the AI just reasons in a different way. By any means, the AIs are a million times better than us at reasoning, but they reason in a machine way. If you want to do an artistic achievement, a thing that has to look real to us, doesn't fall into the uncanny valley, or simply you want to convey a certain feeling, let's say you want to make a diving exploration game, you want to play with the lights and the colors in a certain way, the machine doesn't know that. The machine will go for the most realistic, physically based calculus on how the light should bounce and everything, how erosion works, but you need to do the extra step all the time, nevertheless. So For me, it's a powerful tool, procedural generation, and I think everybody should employ it as much as possible. Like no time spent in procedural generation is time wasted because you're gonna earn back time from it. It's like dealing with technical debt for who has already had to deal with it. It's a really bad thing, but it's a really good tool, and I think it can allow us to get better and better games, better and better content. Again, this was a gaming focused presentation, but I know that some of you are interested in simulation and in like test drives and other things, and you need to perhaps procedurally generate huge words with believable structure and like adherent to the real world. So this is the most fancy part that you don't really possibly have to care about, but still, it's important to say that human oversight will never be useless. Will never be useless. So, if you have any question, I think we saved up a lot of time for questions. It's much. Okay. You stranger on the first row. I think we may need a microphone, please. I mean, if you shout really hard, they hear you, but perhaps it's better with a microphone.
Thank you for the talk. Everything is very interesting, and I'm curious to see how you will push this inside your actual production. I will take this from far. Have you also had the chance to work in procedural generation with level design recently?
I like this recently. I know where this is going. So I'm gonna say this sadly. I'm gonna say this once. I will do no comment on anything related to Cyberpunk. Sadly, I would like to tell a lot of stuff about it because it's really cool working on that, but I can't. I can tell you this. Yes, level design and procedural generation can go hand in hand. Just look at Diablo. Diablo is actually a pretty cool example of how proper procedural generation can work in a game and make it look autorial. Example given, most of the levels of Diablo are rolled, but they still take care of level design principles. So avoid backtracking, placing bosses in the right room so you can actually tell what's going to happen, giving a good scale of reward length of the dungeon. So the longer the dungeon, the better the rewards, or the pacing of enemies. This is all stuff that is actually like it's the job of a level designer. Like technically, a level designer should actually lay down all this stuff. You can do it in procedural generation, but then again, you need the level designer to tell the programmer, yes, we should generate the dungeon this way. And in the case specific of Diablo, the technique behind him is node-based. So every time you have a piece of dungeon, it's an actual node built from like other pieces assembled procedurally, but you know that node has parameters, and those parameters are actually dictated by the level design. So yes, they work hand in hand, and actually procedural tools are actually done for level designers. I give you an example. Pro Builder, it makes you generate geometry on the fly, and there are other plugins like Pro Builder that are like Dungeon Architect, which also allow you to generate a game-ready dungeon by just laying down the parameters and the basis exactly and choosing the shape of the level. So yeah, I think I think it covers the level design as well.
Another small one, if I may. Do you have any example which the texture generating procedural generation is pushed a lot in a game at the top level?
Well, I can tell you in advance that as we see it, as I've shown, I mean, Diablo and No Man's Sky are really a big example of it, because they are both games that like generate a lot of stuff. I think that most games actually, in terms of gameplay, there's pretty much a solid 70% of games that actually want to generate stuff procedurally. And in terms of actual assets generation, I would say a 99% of all the big major company they do procedural stuff. They work with procedural because the amount of work is just too much. I mean, I could tell you that pretty much all the georealistic maps you've seen, so even the GTA 5 map, is actually procedurally generated. You use now Word Machine to make landscapes. Word Machine is a procedural generation of landscapes, and it's pretty much used by everyone.
Thank you.
It's not much of a question, more of a curiosity. What is the weirdest stuff you have seen that was procedurally generated?
I mean, aside from the creatures from No Man's Sky, some of them are pretty messed up. The weirdest stuff is usually when there is something wrong, like when you have like a little thing that is just out of place. I remember when, for some reason, we were starting to generate landscapes, like pixel-like. They were supposed to be like a realistic game, but it was like Minecraft, and all the steps, like it was all in steps, and all the steps were cut off from each other. And we also ended up that half of the world was like moved 50% left on the other half of the world. And when people were generating this stuff, they were like, "What the hell is going on? I don't even know where to start." Turns out that it was a coordinate problem, so it was a really tiny thing that messed up everything. I mean, if I were to list all the weird stuff, would be a pretty long answer, to be fair.
Thank you.
It was really clear how much is convenient for the asset production to use procedural generation, but I'm wondering how quality assurance can deal with the world fully procedurally generated, and are there any best practices that should be taken care of dealing with that?
This is a pretty valid question. So, okay, aside for the first one, I'll tell you, depending on the type of company, you actually have a team devolved entirely to quality assurance. All AAA companies, like all companies with more than 50, 70 people, have at least a couple of QAs that only check if the assets being added to the project are legit and they work right. Still, as a technical artist, I need to make sure that the thing I do are as foolproof as possible. So it's true that there's a lot of oversight. Again, the reason why we need human hand, and it's like we need oversight. We need to make sure make sure that what is procedurally generated looks decent and works. For me, for instance, I wouldn't be allowed and I wouldn't dream of adding to the project as a procedural system that is broken or that has a set of settings that just make the game explode. I would get scolded for that, and rightfully so. And for the second part, so it's the best practices for procedural generation is mostly the first one that comes to my mind is make it zombie-proof. What it means, if you put a zombie on the front of the PC and it just clicks forward, forward, forward in the game, in the wizard, like in whatever editor makes the procedural generation, the final results should still look decent. So as little oversight from the artist, because procedural tools will be used from the artist, and sometimes artists have deadlines. So my first thing is make the UI idiot-proof. Like, really, try to mess it, when you develop, try to mess it up, try to break it, give it the most weird values that you can, and when you see that going over a certain value makes it break, or you need a default value, go for it, but crash test it. Like, this is my first best. The second best practice is it has to be convenient. So I've seen people making procedural generation that required 15 easy steps to get this started, the generator started. No. Please don't, because we need to write a guide and the documentation just for the editor before even starting to describe how to use it. No, make it simple, make it streamlined, because at the end of the day, you want to save everybody's time. You don't want to waste anyone's time. So these are the two things. In terms of the actual techniques, try to keep it as simple as possible. So the moment you know that you can actually make it simpler without breaking a requirement, try it. Perhaps, it was more complex for a reason, because there was a special case of generation that would break up everything. But try to simplify as much as possible any technique of procedural generation.
Thank you very much.
Cheers.
Okay, my question is about, okay, you show us some tools to use generation for modeling or creating assets and so on, okay. But a more generic approach, if you have some structured data that you want to represent with that is a sort of fractal data, okay. That might be data for a game or for everything. We have tools to do this kind of produce this kind of data. Okay, not so for the specific application it shows to us.
Well, it's supposed to be modular as possible. So once it's developed a tool set, like an example, Udemy. Udemy is the program of choice for many procedural generation because it's a standard program that works with pretty much everything and it does pretty much whatever you want. May it be VFX for movies, maybe content for games, maybe content and physics simulation for like realistic tests. Udemy usually does a lot of that. It's good to standardize these kind of things so it can be reused in many other ways. Sometimes it's necessary to reinvent the wheel though, because you have a program that works for you and works really well, but perhaps there is this tiny thing that you need different. And you may want to develop your own set of tools, especially if it's overkill to, for instance, getting a 5,000 euros license per seat of Udemy if you don't really need it, like if you don't really need that tool specifically. So you may want to rewrite a tool that already exists, but it's like more focused on what you actually need. No, just the tool. But at the end of the day, it's like most standard mathematical libraries already include Fractal, Voronoi, and Gauss. So yeah, you don't really need to rewrite the basic framework, to be fair. Was there anyone? Yeah. No.
Hi. This kind of tools applies to environments which are fantastic or not realistic. What about procedural generation of realistic cities, models? Can we take a picture of an environment, maybe a modern city, and then try to reproduce it through procedural generation?
Absolutely, yes. I mean, some of the pictures I've shown were a bit more on the realistic side. I didn't show anything actually photorealistic. But yes, you can do that. The limit is given by mostly two things: how much time you can spend on it and what's the technology available at the time. Of course, if you were in 2001, you couldn't get photorealistic stuff, neither by hand or like with the procedural. The thing is, if it can be done manually, there's a chance that it can be done procedurally. Realistic cities can be generated. Like there's a game called The Crew. Has anyone played The Crew? Yes, yes. That game, you could see. You could travel by car with the entirety of the US. The entirety of the US, from New York to California, you could just drive, no loading screen attached. The thing is, okay, the world was shrunk, but it was procedurally generated. Most of it was procedurally generated. Of course, the landmarks not. Like you would like to make Mount Rushmore manually. But everything else was generated procedurally, like all the towns and cities. So yeah, you can totally do that.
Ciao, compliments for a really great presentation. I have a question regarding the textures you showed before, the procedurally generated texture. Can you give us an idea on how much the programming time is required to get to that level of detail?
You mean this one?
Yes.
But this is no programming. This is only tech. This is tech art. You open Substance Designer and you work with nodes and visual scripting. It's really, that's why I say it's a really powerful tool, because this is, it can be done in a couple of days. This is like a couple of days worth of work if you are master of the program. If you are not so skilled, you could take a week. But you could parameterize this so it actually makes different buildings. Why not? yeah, that was pretty much it.
Okay, always about that texture, the last you showed. Does it work even if you change the angle of the camera or the angle of the source of the light? Because
yes, it does.
So it totally emulates like a 3D module.
This one, okay. This one specifically uses tessellation. What is tessellation? Is when you get closer to an object, the shader knows to draw more triangles on it. So this is not even parallax distortion. This is tessellation. This is like, it looks legit 3D. Like as you can see here, like you can see the border revolving around the sphere, regardless of the angle. And the normal map takes care of the lighting. So as you can see, like this is a 3D part here, but it's considered as like one direction, being one direction in 3D. And the normal map is pretty good at simulating that. So yes, the building would look legit. You could walk around it, and it would look completely 3D.
And how much computing power does it require compared to a 3D module?
This is another good question. Especially this one, if you use it for a single instance, it would take more processing power than making the building in 3D. Especially because tessellation doesn't care about optimization of surfaces. So it would like just make a super small grid, like super high density, and distort it. So it's not as optimal as making a legit building. But if you were to instance this material and reuse it for any other structure, let's say you make a shader out of this, you make this as a shader, and you feed parameters, which may be the brick type, the type of window, whatever you want really. You could have a material instance to cover like an entire historical city done with a single material and all its instances, and it will weight much less because the tessellation fades away as you get away from the building. So it would automatically turn into a level of detailed version.
As you told us, there's always a human hand in setting the parameters for the procedural generation, and at the end there's always a human eye to judge if the procedural generation has been good enough. How close are we today in adopting techniques such as machine learning to judge the results of procedural generation? Are we there yet?
They've done some attempts. They are terrible at the moment, so we're not really close yet. Okay, they made a playable game using machine learning and AI, so you could have the make game button, but the difference is the quality. The game that was generated was a simple RPG where you could like just walk around with a character in a randomized terrain and eat some enemies. There was some environment to it, and there were some basic quests like kill enemies. You can't really write a good story procedurally, can you? Like we're already barring off all the games that have a narrative are already barred off, for instance. Aesthetically speaking, yes. Also aesthetically speaking, the thing is, let's say that we can even make procedural the setting of materials for this material instance, as I gave the example before. But will the city look nice? Will the palette of buildings look coherent? No. And machine learning can tell us there is a huge database of historical building and say this is likely to happen, this is possible, this is plausible. But this is pleasant? No.
Okay, it's an aesthetic problem.
Yes. And I think it's going to always be like that. And also, people like to be authors of their games. So no one really wants to press a button and say make game. And even then, you need to make base assets and get the base data for the procedural generation. So it's not really just a button. It will never be just a button.
Okay, thank you.